5.7, number 398 to illustrate this. So it says find the antiderivative of dx over root 1 minus 16x squared. All right, even the book's formula for these particular types of problems would not really cover this one in totality. So you would still have to use u substitution anyway. I'm going to use u substitution on all of them, wherever it necessitates it, and I'm not going to resort to the special case formulas that the book has in the beginning of this section. If you want to, that's fine. It doesn't really matter. But that's not my approach. So what I do here first is I look at which particular inverse trig derivative does the integrand appear like. So I'm first going to remove the dx to the outside, as I mentioned before, just for visual clarity, nothing more. I don't think it's a better way to write it in general, but I think it does give more visual clarity to what's going on. So once I have this, looking back, well, this looks mostly like this scenario here. It's got a root, it's got constant minus something variable squared, right? That's the way to think about this. Not necessarily number one, but just constant minus something squared, right? That's the way to think about these. So it looks mostly like the sine inverse. So I'm going to copy it and reconstruct it in some way based on the sine inverse here. All right, so the first thing to do is I need to get this little expression here to change into a perfect square, right? Right now it's 16 times x squared. So what I can do is I can replace the 16x squared with u squared. Okay? So let's just think of that for a quick second. U squared would be 16x squared. Okay? Now, if u squared is 16x squared, right? So therefore it reads 1 minus variable squared, which is the thing I'm trying to copy here, right? 1 minus variable squared inside that integrand there. So that means u would have to be 4x. Right? If I take the square root of both sides, take the positive version of it, I would get u equals 4x. So therefore, I should let u equal 4x. When I do that, we're going to get that du is, of course, 4 times dx. Right? And over here, we do not have a 4dx. Just got a dx. So therefore, like always, the constants are easy to push around. Constants and negatives, easy to push around in all these types of substitution problems. Don't ever concern yourself about that. 1/4 du equals dx. So now dx here will be replaced with 1/4 du. And down here, 16x squared will be u squared. So therefore, I will have 1 minus u squared down here, and it will look remarkably like this expression in u. That's what we're going for. Trying to copy that structure. The 1/4 I'll push to the outside. So we'll have integral 1 over root 1 minus u squared. And I know I'm going to put 1/4, I'll just go ahead and write it, 1/4 du. We want to push the 1/4 to the outside, so 1/4 goes out there to clean up the integrand a little bit, make it a little less confusing. 1 minus u squared du, but we know that 1 over the root of 1 minus x squared dx is sine inverse x, so therefore it's just a different variable, but it's the exact same structure, so therefore it must be 1/4 sine inverse u and plus the arbitrary constant because it was an indefinite integral. Now I just go ahead and replace u with what it really is, which was 4x apparently. Okay? So we have our answer to this antiderivative. It is 1/4 sine inverse 4x plus c.